Okay, guys, let's look at concept number 7, which is calculating the percent composition of a compound. So what does that mean? Well, there are two equations that you are going to need. The first one is the percent composition if you have experimental data. So experimental data is data that you get from doing an experiment in a lab situation. So your equation would be to calculate the percent by mass of the elements that make up a compound. You would look at the mass of the element divided by the mass of the total compound times 100. And that would give you the percent by mass, and you would have to do that for as many elements as there are. The second equation that you're going to need is the percent by mass from the chemical formula equation. And this would be if you have a compound. So the mass of one element in 1 mole of the compound divided by the molar mass of the compound would have to be times by 100 to get the percent by mass of the element. Again, you would have to do this for every element that you have in the compound. And all of these percentages need to total up and equal 100%. So that's your way of checking to make sure that you did it correctly. Let's look at an example problem. Example 1 says there is a 100-gram sample of a compound that contains 55 grams of element X and 45 grams of element Y. What is the percent by mass of each of the elements? So you would have to use this equation. Mass of the element divided by the mass of the compound times 100 is going to equal the percent by mass. And you're going to have to do it for both element Y and for element X. So the first thing you would do is plug in. Let's do element Y first. You look at 45 grams of Y over the 100-gram sample times 100, and that would give you a percent of 45% of element Y. You would just type into your calculator 45 grams divided by 100 grams times 100 equals 45% of element Y. For element X, you would do the same thing, just use the element X information. So that's 55 grams of element X over 100-gram sample times 100 is equal to 55 grams of element X. Next, the entire answer for this question would be, so out of an 100-gram sample, 45% mass is element Y and 55% mass is element X. Now, this is the example that if you were given information that you collected from an experiment. Now let's look at a different example, example 2. Example 2 says that you're given 1 mole of NaHCO3. And then what are the percent compositions of NaHC and O? So for this one, it's a little bit different. Since you're given 1 mole of a compound, you're going to have to calculate the molar mass of the compound, and then you are going to have to calculate the mass of each element present in that compound. So let's walk through first how to calculate the molar mass. Now remember, this is concept 4, and if you're on this concept, which is concept 7, you've already mastered that, so you should be able to do this very quickly. So we're going to look at and calculate the molar mass of this compound. So we're going to need our periodic table because we're going to need all of these values. Now first, let's look at sodium. We have 1 sodium in the formula of NaHCO3, so we take 1 sodium atom times the mass of sodium, and we get that is going to be equal to 22.9 grams. We have 1 H in our formula times the mass of H off the periodic table, and that's going to be equal to 1.00797 grams. Then we also have 1 carbon in our compound times the mass of carbon, which is 12.010 off the periodic table, and that's going to give us a mass of 12.01 grams. Then we have 3 oxygens times the mass of each oxygen, which is about 16 grams, and then when we multiply that together, we get 48 grams. Now remember, these are just the masses of the individual elements. We need the mass of the total compound, so we need to add up all these values. So that's what we're going to do. We're going to take 22.99 plus 101.00797 plus 12.01 plus 48 grams, and we get a total molar mass equal to 84.01 grams of this compound NaHCO3. Now this is just part one. Part two, now you have to use our equation. So you need to calculate the percent composition by mass of each of the elements in the compound. So we're going to have to use the equation above. So for Na, we take 22.9 grams. Since there is only one Na in this compound, we only need 22.9 grams of Na over the total mass of NaHCO3, which is 84.01 grams, times 100, and we get the mass percent of sodium is 27.37%. For hydrogen, we take the mass of the one hydrogen, 1.00797 grams. We divide it by the total mass of the compound, which is 84.01 grams, times 100, and we get 1.200% hydrogen. For carbon, we have 12.01 grams of carbon, since we only have one carbon, divided by 84.01 grams of NaHCO3 times 100, and we get 14.3% carbon. And for oxygen, we take the mass of the three oxygens, which is 48 grams, divided by 84.01 grams of NaHCO3 times 100, and we get that percent to equal 57.4% oxygen. So the total percent composition of NaHCO3 is 27.3%, 1.200%, 14.3%, and then 57.14%. Now, the trick with these is that to make sure you did it right, all of your percent should add up to 100%. So if you take 27.37% sodium plus 1.200% hydrogen plus 14.30% carbon plus 57.14% oxygen, you will get a mass or a total of 100%. Now what I want you to do is I want you to go into your bucket and complete the next few problems and then submit those onto Sakai.